And welcome to my channel. So in this video I'm going to cover the solution to this question and also do some live coding work. At the same time, I'm going to briefly cover the general steps we should follow in a coding interview by solving this problem following those steps. So before we start the real content for today, I would really appreciate that if you can help subscribe to this channel. So let's get started. First, let's read through this problem. You're given an integer array coins representing coins of different denominations and a integer amount representing a total amount of the money. To return the fewest number of the coins that you need to make up that amount. If that amount of the money cannot be made up by any combination of the coins, then we are just going to return -1. So you may assume that you have an infinite number of each kind of coin, so which means we could use each of the coins as many times as possible we want. So let's see some examples. For example, this 1, 2, 5, 3 kinds of coins, and the amount is 11. So the output is going to be 3. We just have 2, 5, and a 1. So let's see some constraints. It says that the coins, so we have like we have 1 to 12 kinds of the coins, and each coin is between 1 to max of int 32. Amount is between 0 to 10k. So that's pretty much it. So regarding the edge cases, not too much of the room to think about edge case currently. So let's see how to solve this problem. So what we could do is brute force. If we go with the brute force, we could use DFS to enumerate all the possibilities, and then try to find the one way that needs the least amount of the coin. But that one is going to be quite brute force, which is going to be not good regarding the runtime. So instead, what we could do is we could use the dynamic programming to solve this problem. So for dynamic programming, first of all, you need to define the problem. Like the problem we need to memorize. So let's define the 1D array, one-dimensional array called DP. So let's define the DPI as the minimum number of the coins needed to get amount I. So this will be DPI. So the next thing is we decompose the original problem into subproblems and try to get the formula. So I would say DPI is mass.min DPI minus, so let's say this is coins k plus 1. So suppose we already have all the answers to the subproblems. We can just try to enumerate all the possibilities. So for example, we have those kinds of coins. It is just a one. So if we have like this, the answer to the subproblems, which is one step away from the original problem, then we just need like one additional coin to get amount I finally, based on the subproblems, which we already have the answer. So k is anywhere between 0 and coins.length -1. So as I said, it's just we enumerate all the kinds of the coins, which is just one step away from the original answer. So that's pretty much it about this formula. So the runtime is going to be linear to this amount, and the space-wise is going to be the same as that. So let's do some coding work for this solution. Let's say if we have, well, let's see, I would say int, let's see, so if it says that the amount, it can be anywhere between 0 to 10 to the power of 4. So I would say if the amount is equal to 0, we're just going to return 0 finally. So if it is a non-zero stuff, so let's see, we could yes, or maybe yeah. So I'm thinking what I could do is, so instead of that, let's say dp is equal to new int amount plus 1. So of course we will have the dp0 as 0 currently, and then we are just going to go through everything. So I is equal to 0, I is smaller than or equal to amount. It'll be just from 1, and then plus I. So you're just going to try to. Okay, so I think I think I did I mentioned something wrong. So the runtime is going to be linear to O. It is going to be O amount times the length of the coins, but it is still linear to the amount. That is because we have just up to 12 kinds of the coin. So but it's worth to mention that it is something like that. So I is equal to 1 as smaller equal to amount plus I. So we are going to say that this one should be, you're going to enumerate all the coins here. Putting all the coins. So if I is larger, if I is smaller than the coin, we're just going to continue, because the coin, so let's say the coin is 5 and we are trying to compute dp4. Of course we cannot make use of the coin. So the next thing is, what we could do is we could use dp I is equal to max dot min. I think I forgot to fill this one. So I would say I need to fill everything. I is equal to 1. I is, or maybe you don't need to do this one. You just need to enumerate instantiate as max dot integer dot max value at the very beginning. So dpi is equal to this one, or it could be dpi minus the coin. So that will be it, and finally we are just going to return dp amount. So let's take a look at this one. First of all, we initialize this, and then we try each of the coin here, and it really depends on the answer of that. Just one step away from it. We try any one step away is a problem. Alright, so seems to be fine. Okay, so let's give it a try. Let's try. I'll just rely on this platform to help us to do debugging for simplicity. Okay, so there is some wrong answer here, which is output is actually so we have 3 minus 1 0 1 2 3 1 2. Okay, so if that's not true, I think I have something that's not true, which is this one. If there's no answer, currently I'm giving a minus. So let's see how that could be possible. So you have dpi at this one. We try, so the amount is 3, and we try to get the amount 3. Maybe let me just try to output everything to see what it is. I is equal to 0, I is smaller than amount I. So this will be I, and then dpi. So 0 0 2 is as 1, but why we have 3 as So 3 actually it is based on, oh, I see. So I think I understand why it is wrong. So I would just set it as amount plus 1. And in that case, and finally we are going to say, okay, dp amount, is it equal to amount plus 1? If yes, we are going to return -1. Otherwise, we are going to return dp amount. So the original thing can get us some overflow stuff. Alright, so I think this should be able to help us solve this problem. So the reason I set it as amount plus 1, that is because we try to avoid any overflow stuff, and the amount is anywhere between 0 to 10k, which is much smaller than the max value for the integer. So I think currently we should be good. Let's do a submission. Alright, so it seems like we are good with this solution. And that's it for this question. If you have any question regarding the solution, feel free to leave some comments below. If you like this video, please help subscribe to this channel. I'll see you next time. Thanks for watching.